So let's try another one of these examples. Let's look again where we've got a normal distribution, we've got a mean of 100, we've got a standard deviation of 15. We want to look at what's the probability of getting an IQ for a randomly selected person between 70 and 130. And again, we're going to use the same trick that we used in the previous video. We're going to use the z-score to convert from the problem where we have a normal distribution into a problem where we have the standard normal distribution. So let's look at this. We want the probability that the x value is between 70 and 130. So in this case, in the previous case, we had to just convert one number to a z-score. In this case, we've got to convert two numbers to a z-score. So the equivalent question is, what is the probability that you get a z-score between, well, what's the z-score for 70? Well, to calculate the z-score for 70, again, we take 70, we plug it in for x on our formula for z-score. We'd get z equals 70 minus the mean is 100, and we divide by the standard deviation of 15. When you plug this into your calculator or just calculate it in your head, you will see that the number that you get here is -2. Similarly, if we take 130 and plug it into this formula here for z-score, what you get is that the z-score that corresponds to 130 is 2. So the 70 gets converted to a -2, the x turns into a z, and the 130 turns into a +2. Now, what we're going to do is we're going to calculate this, and we can calculate this using our calculator function again, normal CDF. And we put in -2 and 2 for our lower and upper limits of where we're interested. This is from -2 to 2. And this one, when you plug that in, you may actually remember that's our 2 standard deviations from the mean, which means it's going to be 0.95, but let's figure out, let's put a couple more decimal places of accuracy in there. Normal CDF, -2, 2 is 0.9545. And this is what you would do if you have 2 values here and you're trying to calculate the probability that you randomly select something from a population that is normally distributed, and you have a lower limit and an upper limit, or a lower bound and an upper bound.